Hello everyone. In this lesson, we are going to learn about robots and coding. And within this scope, we will study the diversity of educational robots, the basic robotic anatomy and functions, and basic concepts of block-based visual programming language and other ways to program robots. As you know, the use of robotic applications in education provides students with significant gains. In recent years, there is a growing interest in including coding activities and work with robots in early education. Representing mathematical ideas with materials is an important component of early years mathematics learning because it concretizes abstract ideas and makes them accessible to reflection, fosters meaningful understanding and organization of simple reasoning and, later, generalization into more complex thought processes. Educational robotics enriches learning environments because it promotes very practical contexts of experimentation and challenge solving. For example, the materialization of thought can occur with the definition of a robot's action, as it allows children to make reasoning real and test it in a tangible way. When solving robot problems, children need to understand the problem, develop conjectures, test them and if wrong, rethink their conjectures. This path of materializing thought through robots helps develop abstraction processes and prepares children's abstract thinking for programming, in playful contexts for meaningful learning. When working with educational robotics, we consider the elements of the exploration scenario. The hardware of educational robotics consists of three components. Actuators are the motors that introduce movements. Effectors are the devices that enable robots to move, change shape or interact with the environment. And sensors are used to read the environment, for example, to recognize an obstacle. The software of educational robotics can be through procedural programming and sequential instructions or programming by blocks and by defining objects, their properties and behavior. When a robot is programmed, it will have the ability to move its components through actuators. It can act on its environment with the help of its effectors. And it will have the ability to recognize its environment through its sensors. There are three types of educational robots. These are ground robots, construction robots and humanoid robots. The examples of ground robots are Doc, Bbot, Mbot, and Kibo robots. The examples of construction robots are Lego and Topobo robots. The examples of humanoid robots are Pepper and Nao robots. To reach the links to the videos that introduce these robots, you can visit our project webpage www.mindmaths.org/educational-robot-videos. There are different ways or languages to program robots. For example, the Bbot robot can be programmed to allow the development of spatial orientation activities such as forward, backward, right, and left, with indicative arrows activated on the robot. In this case, the students previously record the movement of the robot by using informal representations such as the following. There are other ground robots include the possibility to define cycles of movements enabling the exploration of patterns in mathematics such as the Kibo robot. Extending the possibilities of robot programming, there are several examples where the programming language is visual, such as the Mbot robot that can be programmed using block programming. The algorithms for controlling the robot and the associated sensors are built in the mblock software that uses the block programming logic of Scratch. Now, let's see an example in which the Mbot robot is programmed to follow the black line using its line follower sensor. Let's see the learning outcomes for this session. To develop skills to introduce robotics into the curriculum without a great prior technical knowledge. to explore the diversity of educational robots, to understand the basic robotic anatomy and functions, to understand the basic concepts of block-based visual programming language, to know how to select robots according to students, contents and exploration contexts. That's all for now. See you at the lesson. Bye. For more information, you can visit our project website www.mindmaths.org and see the output section to reach various topics regarding the use of robotics and other technologies in primary school mathematics lessons.